Okay, yeah. Hello, everyone. I will talk some about anti-patterns in event-driven architecture. Some things that I stumbled upon the last couple of years when working with event-driven architecture. Usually, as you know, it's not really like a one-size-fits-all, and the answer is always like it depends in software engineering. But these are at least, I think, some things that you should keep in mind when working with event-driven architecture. So my name is Jim. I work as a backend developer consultant at Polestar currently. I've been a developer for around 10 years. First 3 years, full stack developer, and 7 years after that, pretty much backend developer, working a lot with .NET and C#, REST APIs. I really like working with event sourcing, spent some years with that, and also event-driven architecture. Event sourcing we won't really talk about today. Instead, we will just talk about event-driven architecture. I also like to work with like a DevOps team, work together with UX people, front-end developers, together with backend, and monitoring application, look at response times, stuff like that. Sometimes I blog at steadycoding.com, so feel free to take a look there if you want to. But yes, let's just set the stage or so, like an agenda of the different anti-patterns that I will go through. So it's like 7 in total. First one is ignoring idempotency. Idempotency, I think, is a bit of like a hard word to understand. So I will explain what that means in a second and why it is important to understand in event-driven architecture. Then we will see about correlation. One of the problems, of course, with distributed systems is that it is sometimes hard to know if something happens in application A, what is like the outcome or the effect in application B. So we need some way to correlate information. So we'll see about that. Third one is treating events as command. Kind of like the name implies, event-driven architecture. All we talk about is events. But sometimes it might make sense to explicitly call them commands instead, if that is what it is. So we will see about that. Fourth one is thinking event-driven architecture is decoupled by default. I don't think this is the case. On a technical level, maybe sure, but you can still have very tight coupling even if you do event-driven. So we'll see about that one. Point 5, events designed by data. So usually when you like create the events or design the events or so, it's easy to like think about information all the time or data. Like we put data in the events and data is what we care about, right? But this can lead to like a bad design or so between the systems. So it's much better to focus on behavior instead. So we will see an example of that. Point 6 is not using a dead letter queue. Usually, I mean, when you do event-driven architecture, you have some kind of queue. You can also have like a separate queue sitting besides, which is known as a dead letter queue. So I will explain why that one is good to have. And the last tip is not checking retention days. I think the word might be different, of course, depending on like what cloud provider you use. But usually, in my experience, retention day is like a common term or so, meaning the amount of days a message will be on the queue. So we will see why you should take a look at that one. But first we dig into the first anti-pattern. Let's just get a quick like overview or so what we even mean by event-driven architecture. The first example is actually not event-driven at all. This is like a traditional HTTP call that I think most of you are familiar with. So usually we have like an application A talking to application B made by like an HTTP request or some kind of like protocol at least to make like a synchronous invocation. This is pretty much like a laser point, you could say.
Sorry, I'm late. I came in now, so you know it, man.
Sure, welcome. So usually have like
Thank
an application A that's talked to application B by a synchronous call. Application A then of course needs to like know where application B lives or so, at least by the URL. It also needs to know some kind of contract, what properties to send, what the application B expects. So this is like the traditional way or so. Still useful, but it's not event-driven. But what we will talk about today is, of course, event-driven. So you can still have application A talking to application B, indirectly at least. But instead of making like a direct synchronous call, you usually have some kind of queuing mechanism in the middle. So in this picture, for example, you have application A, then is decoupled from B. So A sends a message to the queue instead of the topic. And then at some point in time in the future, could be like a few milliseconds after, could be an hour, few days, we don't really know really. But at some point in time in the future, application B will receive the message. During this presentation, I might use the word event, message, or like notification a bit interchangeably. They're pretty much the same thing. Usually the name can be a bit different depending on like the cloud provider or message broker, but keep in mind just that event and message and notification is pretty much the same thing. Also, it's worth to mention that usually when you have just one consumer, as in this picture, we have just application B, then it's usually a queue we have in the middle. So when you have one consumer, it's usually a queue. If you have multiple consumers instead, so let's imagine we had like application C and D as well or so, then it's usually known as a topic in the middle.
Sorry, I'm late. I came in right now, just,
Then you have like a topic instead. So application A sends a message to the topic, and then that would be like copied or forwarded to all the subscribers. So I have used Azure, and in Azure Service Bus, they call it like a topic and a subscription. If you use AWS, you have something called like an SNS, which pretty much is a topic, and you could connect that to an SQS, which is a queue. So if I, during this presentation, say like topic or a queue, that's because the difference isn't really important for most of the anti-patterns. So just keep that in mind. If it is very important that it is a queue or a topic, then I will say so explicitly. But yeah, now we have like a good, at least, foundation of what event-driven architecture even means. So let's take a look at the first anti-pattern. That is ignoring idempotency. So idempotency, I think, is pretty much easiest to almost explain with a traditional HTTP GET, for example. If you do an HTTP GET, you can invoke that like once or twice or 100 times. It doesn't really matter much because the effect is pretty much the same always. Of course, the information might have been changed between like the operations, but assuming nothing changes, you can invoke it once or twice or 1,000 times. The side effects are really like the same or none. So that means that it is an idempotent operation. And this is important in event-driven architecture as well, as we will see with an example now. So let's imagine you have an event with an event name, customer information added. You have a first name and a last name. I've removed a lot of information just to make like the event easy to understand. Usually application A sends the message and B will at least 1, receive it, 2, process it, and 3, complete the message on the queue, telling the queue that I'm done with this message, I am successful, please remove the message so I do not get it anymore in the future. That's what step 3 means. There can, of course, be some problems here because let's say, for example, that the process step number 2 fails. If that's the case, it's usually not much of a problem because the message won't be completed and you will get the same message again next time you start up or so, application B works. But it can also be the case that process number 2 actually succeeds, but step 3 complete fails. In that case, you have processed the message, but you haven't told the queue that you have. So the queue will give you the same message again in the future. So it's much, you should have like a perspective that even though it feels like things are done like exactly once, you always get one event once and that's it. That's the wrong perspective. You need to have the perspective that everything is delivered at least once. And that is why idempotency matters, because you need to take that into account. And one way to do that is to include an event ID or some kind of transaction ID or like business happening ID in the event to make that explicit. So a better way, if we have like a similar example, is to note now that in the message, we have an additional property called the event ID, which is a unique GUID. In this case, the message receiver application B, you see it still has 0.1 receive, but then step 2 is to, like, in an internal database, just check if have I processed this event ID before or not. If it has processed it, you can just like go to step 5 and complete it, because we are already done, right? But if you haven't processed it, then you can continue to step 3, do whatever you want, and then step 4, persist it in like an internal database for application B. So we know that we have processed it. If you do this and step 5 fails, you still are like fine or so, because even if the queue gives you the same message again, step 2 will make sure you don't process it again. So that's like, so we said that you process the message and you save the event ID, then you complete it. The completion might not work. In that case, you're like, you still make sure you don't process it again. But it can also be the case that even if everything works and step 5 completes, now let's imagine you have multiple listeners. And this is a bit depending on the cloud provider, but if you use Azure Service Bus for instead, if the message is sent to a topic in the middle, if one of the subscriber fails, when you replay the message, it will get to the topic again and every subscriber will get it again. So in those cases, you kind of need to take that into account and to be able to handle it, the same message again as well. So that's why you need to like think about the idempotency. So that's the first anti-pattern. Second one is no correlation metadata. One of the problems with distributed systems is that tracing is very hard. One of the problems with distributed systems is that tracing is harder. The good thing with the monolith is that you usually have like a stack trace if something blows up, but with distributed systems, you don't have that. So let's imagine that you have like an event, customer information added with an event ID. If application A sends this message or publishes it and application B receives it, you usually need some kind of way to like correlate it to see that application A indeed did send the message and B received it, because there could be more systems as well in the picture, right? So you need to be able to trace that. One way to do that is to, I mean, even if they log separately, you could use like timestamps or so. That's not recommended. If you have very, very low traffic, can work, of course, but it's not like recommended or so. A way better way is to like always log centrally to some kind of logging system. I've used Elasticsearch, but there is other on the market, of course. You can use anything that your company prefers, but you should have some kind of centralized logging at least. Then you can include the event ID there as well. So make the event ID queryable. And actually, you should also have some kind of correlation ID. So the difference is that event ID usually represents like the business transaction or represents this exact event, and is usually created when you like instantiate the event. But you can also, it's also useful to correlate what the end user is doing, like if you have a front-end application or so. So correlation ID could more be like when you press a button, you instantiate the correlation ID and send that throughout all the systems, include it in the event, for example. And then you can log both correlation ID and event ID. So you get like traceability, both like for this specific event, but also on this like specific like click of a button, so to say. So this is, if you could probably have like a separate talk on just correlation, because that's a big topic by itself. But if you can take like one thing away from this anti-pattern is it is perfectly fine to include more information in the event to make the correlation and traceability easier. That's like the key takeaway. Anti-pattern number 3, treating events as command. As the name event-driven architecture applies, we always think about events. One of the bad things is that it can actually hide coupling sometimes. So let's imagine that you have like an event customer information added, same ones before. If you publish this event and you only really have exactly one subscriber, and you also publish this because you want that subscriber to like notify the customer in some way, it could be send an SMS or an email or something, but you as a publisher really have expectations on the consumer to do something very specific, then it's really not an event. You should maybe consider naming it as like a verb instead, and treat it like a command. So you could change it to like a command name and command ID. On a technical level, there is not much of a difference really. It's more like a semantic difference, but I think it can be useful because this reveals the coupling way better than just an event. Because when we have an event, we think that it is like they are not related or so, the systems. But if it is really just one consumer, then it could be seen as a command instead, because you as a producer really have some expectations on the behavior of the consumer. So that's one thing to keep in mind. Also, I think one of the benefits with this can be that for every developer reading the code, it's a bit more like explicit that we want to notify a customer at this point. So that can be useful to think about. Just a check-in if the voice is still okay on the screen sharing, since I had to restart it.
All is fine.
Yeah, thanks. Anti-pattern number 4, thinking event-driven equals decoupled. Yeah, this one is actually interesting because for most developers, myself included, and I think even like most tech leads and like some managers even, everyone believes that microservices is like the silver bullet. It's always nice. Event-driven architecture is superb because it decouples everything. I don't think that's the case really. Sure, on a technical level, event-driven architecture might be decoupled, but you can still have like behavior or business related coupling. So let's imagine you have this picture, for example. Here we have a bunch of services, systems or microservices or applications. It doesn't really matter, just different names. Important to note here is every arrow you can see, that's an event being said. So I just omitted the cues and the message icons to make it a bit more easier to like see the picture, but this is events everywhere between these systems. So when you take a look at this picture, it's actually a bit hard to see is this like a good architecture or is it a bad architecture? We know it's an event-driven architecture at least, but it's hard to say, is it good or is it bad? We don't really know. And the picture doesn't necessarily reveal that. But one way to actually note if it is good or bad is when you get like business requirements. So let's imagine that business walks in and say that we need a new shipping provider in Australia. Then you analyze the architecture, you see like what systems do we need to affect, to change, to make this business feature available. If it turns out that it is only application G that is affected, that means that for some reason we have managed to put logic related to shipping in one service. That can be seen as a good thing, right? Because you just need to update in one place. On the other hand, if you get exactly the same business requirement, but now it turns out that you need to update application G, A, and D, it tells us that for some reason we have managed to spread out logic related to shipping in different systems or different microservices. And then you need to question like, is this good or is it bad? This is usually like not very good, because imagine that you also, let's imagine that these systems are managed by different teams. Then all of a sudden you need to like synchronize backlogs in order to get this business functionality delivered. So this is an example of it's still event-driven architecture, but that doesn't really mean it's a good event-driven architecture. So that's good to keep in mind. It's only decoupled if the business features are like isolated or so in the different services or microservices. And yes, so event-driven is not the same thing as decoupled. If you regularly, for business requirements, needs to update most of the services or applications, that's more like a distributed monolith. And it's also worth to note that even though we all hate monoliths and they are hard to understand and maintain, it's probably easier to maintain a monolith than a distributed monolith. Because if you have a monolith and you break it apart, then you have a network in between everything. And networks are inherently like unstable. So you will probably have even more problems if you have a distributed monolith than a single monolith. So that's just something to keep in mind. That was thinking event-driven equals decoupled. Next anti-pattern is events designed by data rather than by behavior. So when we design the events, it's easy to think about like data like everywhere. That's what matters. So let's imagine you have this event. You have customer information added. We have the first name and last name. Now let's say that, and you publish this event to some systems. Let's imagine now that someone says that we want to know when the customer is registered because we want to do like something. So they need to know when the customer is registered. And for that, we need like the address for the customer as well. Then you feel like, okay, so we already have one event. It has the first name and last name. Let's just create a new one, customer address added, because it contains the address, and publish that event. So now we can know when the customer is registered. So this is not very good because then you will get into ordering problems, because you cannot usually guarantee the order in event-driven architecture. One of the reasons why you pick event-driven can be because of like high load or so, a lot of things happening. If you want to guarantee the order, it limits the throughput that you can have. So you usually do not want to guarantee the order. So then you will get into problems. A much better thing instead is to like focus on what's actually happening. Well, a customer is registered. That's what we want to know about. So you should ignore those two events at the top and instead focus on like maybe one event instead with an explicit name, customer registered, which has the first name and last name and the address if that's what's interested. Because if you do this, it's much more explicit what's happening and what we want to know about. It better like reflects what's actually happening. It's easy for developers to understand what you're interested in, and automatically you don't really get ordering problems because you just have one event. So this is something you should think about, like always focus on the behavior first and then think about like the information. Yes, that was tip 5. Anti-pattern number 6 is not using a dead letter queue. So usually this is a bit different depending on the cloud provider as well, or the message broker. In my experience, both in like Azure and AWS at least, there is like 3 or 5 built-in retries on the queue. So if application A sends the message and B gets it, if B crashes, that's fine. When B restarts, it will get the same message. If we crash again, you will get the same message again. But then after, let's say now that the retries is set to 3. After 3 retries, the message pretty much will be gone. That's what that means. And that's usually not what you want because you just lost the message. So a much better way to handle that is to like keep the message, but after 3 retries, tell the queue to send the message to a dead letter queue instead. So a dead letter queue is basically another queue sitting besides your main queue. And it's important to note that if you would have like a topic in Azure and you have a subscription, I think they have like built-in dead letter queues by default. So you don't really need to care about that necessarily at the start as a developer because they have it. Now I work in AWS, for example, and if you create like a topic or let's say, just a queue, if you create a queue in AWS, they don't have a dead letter queue by default. So you as a developer explicitly needs to like create or tell AWS that I want this queue and I also want this dead letter queue. So when the queue has made these 3 retries, please send a message to the dead letter queue. And it's also worth to keep in mind that it's probably much easier to at least start with the dead letter queue, and then you might realize that for this specific application, we don't really need the dead letter queue, and then you can just delete it. So that's fine, but it's much harder the other way around. If you lost the message, then you realize that, oh shit, we lost 1,000 messages. Then you kind of need to go to the team building application A and kindly ask them that we lost messages. Could you possibly help us to like resend them again? but that, I mean, takes time from application, the team working with system A. So it's better if you have a dead letter queue, because the dead letter queue is usually controlled by the consumer, application B in this case. So the team managing application B can, whenever they want, replay the messages. They don't need to like take the time from team A. So even though I am a very big fan of developers across team always talking to each other, it's nice to be able to at least handle the retries yourself, so you don't need to take their time for that. So that was why you needed a dead letter queue. It can be good to have. Tip number 7 is not checking retention days. Retention day is a concept that means the number of days the message will be on the queue before it is deleted. So queues do not keep the messages forever. They keep them for a set number of days. In AWS for queues, I think it is 4. You can increase it to up to a maximum of 14 days. So that can be a bit different, of course, as well, depending on the cloud provider. Because in my experience, that usually if you get a message on the dead letter queue, it means that in production, you have messages that you have failed to process. That's what it means. So usually you should handle them with high priority. Try to at least take a look at them maybe the next day or so. But in case something turns up, you need to help a colleague, something else is wrong in production, you like really just don't have time. Then it's nice to know that if you leave like the office on a Friday, 4 days is actually not a lot of days if you have weekends and so. So make sure that you know how many retention days you have. So because otherwise you might send the messages to the dead letter queue, but still they will be wiped after a few days. So that can be good to be aware of, at least, that exists like as a concept, and that the queues do not have the messages forever. So that was the last anti-pattern actually. So I'm just gonna quickly summarize them. First one was ignoring idempotency. That means to be able to handle the same message more than once. Point 2 is correlation. Feel free to add information on the events just for the purpose of making like logging and traceability easier. Point 3, treating events as commands. If you have multiple listeners, multiple consumers, that's definitely an event. If you only have one single consumer and you have some real expectations on what that consumer should do, consider treat it like a command instead. Number 4 is thinking event-driven equals decoupled. As we saw on a technical level, yes, they might be decoupled because you send a message to the queue, not to the recipient. But when talking about business behavior and where you put the logic, you can still have a lot of coupling, even if you do event-driven. Point 5 is when you design the events, always focus around the behavior. Then think about the data. If you focus on the behavior, it will make it easier for you to put like the proper logic or so in the right system. Point number 6, not using a dead letter queue. I would say always start with a dead letter queue. If you feel that you don't need it, that is perfectly fine. Then you can just delete it. But it's much safer to do that rather than not using a dead letter queue and risking losing messages. Point 7, not checking retention days. Just like double check that the retention day is not like 0 or 1 or maybe 4. Can be nice to have a few more days to be able to handle the messages. Yes, that was it. Do we have some questions? I think we had 2 in advance at least.
I started with posting the 2 questions that we got in advance. So Jim, do you want me to read it, or do you see it?
Yeah, I see it. I realized that no one else can write questions, so I should maybe unlock that as well.
I kicked the people out that were destroying, so I think we're good to have the chat again.
Yeah, let me just, I need to stop share, I think, to get those settings. I will do that first and then take the question.
Yeah, that sounds good.
allow participants to chat. Let's cross our fingers we don't get any more trolls. Now you should be able to chat at least. Then I would just share my screen again as well.
You're a Zoom pro now.
Yeah, yeah, I'm not sure, but okay, yeah. So the first question is, how do you make sure that you have the right state across the application when you might not know, and if you don't know the order the events are delivered? Well, you don't know if you have the right state. That's like one of the trade-offs. Event-driven usually means eventual consistency. So you cannot guarantee that you have the correct state everywhere. In a traditional, the traditional monolith or SQL world we all have been part of, then we are comfortable with like 100% consistency all the time. But an event-driven architecture, you don't do that. So you need to slice the boundaries or so between the systems to make that like okay. So you should be comfortable that things will eventually be updated or consistent. The second question is, I hope that answered the first question at least. How do you handle failures or slow responses? What kind of failures are we talking about, and what responses? Is it responses sending the message to the queue, or responses processing the message?
I'm not sure if the person who wrote the question is here, but
yeah, I think I will have to skip that one then, because I think the answer depends a bit on what kind of failures we're talking about. Next question was when to use event-driven architecture. I don't think event-driven architecture is like a one-size-fits-all, or it's not like you need to go, in my experience, it's not like you don't have it or you have it everywhere. For example, I worked in an e-commerce application before, and we had a case where when you made a purchase, when the customer clicked the purchase button on the screen, we needed to notify another, a third-party system that the purchase is made or so. If they were down, that system wasn't working, then we didn't really want the customer to, care much about that. Sorry. So in that case, we just handled the purchase and made a separate little component. And the one single reason that component was responsible for was to notify the merchant that this purchase is finished. And if they were down, it will just automatically retry, because what we just talked about now when you have the queue. So that's an example, I guess, of where you can introduce some kind of event-driven behavior if you feel that fits the solution. So I don't think it's everything must be event-driven. You can probably find some areas in your system to break them apart. Yeah, I hope that answered that question. Customer registered. What about updates? Moves to new address. What is raised? Is that a different bounded context? It's very hard to talk about bounded contexts without knowing seeing a bigger picture of the systems that you have. But at least regarding updates and move to new addresses, this, I guess, it depends really. This is, I guess, one of the areas where theory meets reality. In my experience, people reuse the customer registered event to just publish that again. Then you might need to do some checking on your side that if information has changed and only process it in that case. You could maybe, if you want to have a separate event for it, customer address changed or so, that would at least more explicitly capture what has happened. If you need to do some customer support function that allows some support agent to manually fix an address, in my experience, people usually reuse the events in those cases, but I think that it might be useful to create like explicit events for those. So address fixed by customer agent or so. I hope that answered that question by Olof. Johan, Saga pattern. I haven't really worked much with the Saga pattern actually. So if you have something about it, sure, feel free to mention that, but I think I will have to pass on that question. I know it exists, but I haven't really spent much time with it. And then the same question by Olof. Last question. How do you suggest managing the event IDs for idempotency? Store every ID ever and match against incoming? Yeah, pretty much like that, Arthur. Store the event ID and then just do a lookup for it. Usually, in my experience, that have never been like a problem, even if you have like a million things happening. We, for example, have used like Cosmos DB and Azure for it. And you can keep the event ID like as a partition key. So yeah, that I don't have experience from that being a problem. I hope that answers your question, Arthur. Yeah, thanks everyone for listening. The boring with software development is that the answer is always it depends, but I hope at least some of the like anti-patterns and the solution for them have been helpful at least. So yeah, thanks a lot for listening.